Okay, and then I will try to share my screen. Okay, can you see my screen?
Yeah, we can see it.
Okay, so let's kick off our first meeting. The charter and README for the whole working group has merged, and so basically we are trying to cover a lot of ground here, and there is a lot of issues, as you can see, which are in scope. But we have decided like to mostly focus first on the things that we have already worked on, which include the eviction request and non-maintenance. So I will be talking about the eviction request a bit later in this meeting. And so I think first we could start with like some introductions. So I'm Philip, I'm from Red Hat, and I've been researching this area for some time. And also I have some ties to the SIG apps. So we've had like a lot of people coming in to the SIG apps meetings, basically asking about new like features for disruption budgets and like or changing the behavior of all the workload controllers. Um, okay, so that's basically it. Does anybody else want to introduce? Yeah, go ahead, Lucy.
Okay, yep. My name is Lucy. I work at Uber on platform engineering. In particular, currently I work on a team who a lot of our mandate is looking at how we solve for this exact type of problem when running our databases and data plane on Kubernetes clusters. Outside of that, I've been contributing to Kubernetes for I think just over 2 years. I work with folks in a SIG node quite closely with Dawn, if you know her. And then outside of that, I've done some stuff in Arch before, but not much. Yeah, my interest here is as an end user who, and also from the perspective of making sure we're building the right thing at the right time.
I can go next. I'm Ryan Hallisey, and I work at NVIDIA. I'm interested in this working group in general for lifecycle in Kubernetes, which is just an interesting topic in general, but also for device managements inside of GPU clouds. Obviously, we have NVIDIA has tons of GPUs and internally, and my team has a lot of Kubernetes clusters where we run our GPU clouds. And we face all sorts of different interesting problems with how we life cycle those things in Kubernetes. So we're really interested in um, we've done a lot of work in our experience with how we do life cycle on these things. We're really interested in taking that experience and really bringing it to the community and sharing it. So I'm developing some new solutions in this area.
I can go next. I may cut off a little bit because I am commuting right now, but my name is Jonathan. I'm an engineer at AWS. I'm also a maintainer on Carpenter, and so on the AWS side, I mostly work on the data plane, auto scaling, and I'm interested in node lifecycle mainly because we have a lot of asks from AIML customers that are kind of interested in maybe better ways to automate the process of kind of disrupting nodes in a more complex way rather than just simply relying on readiness.
Um, from Datadog. And I've been doing something similar in the recent years as all of you too. We have built our own system within Datadog that is able to disrupt and evict all the workloads that we are running, if it's stateful or stateless. And I'm here to just see where these steps are going because they have some very good ideas and to see how to integrate our learnings too and see what pain points we could solve.
I'm Joel. I'm a software engineer at Red Hat. I am also one of the SIG Cloud tech leads, so hopefully can provide input where this overlaps with SIG Cloud responsibilities. Internally, I do a lot of work on UX and API design, so also hoping to provide some insight there as these projects need that.
Hey everyone, I'm Peter Hunt. I'm a software engineer at Red Hat, and I work primarily on SIG Node, trying to I'm a tech chair there and build up something good as well. But we're hoping to bring a node person.
Cool. Anybody else? Or
Yeah, can you hear me?
Yeah, sure.
Hey, my name's Alice. I come from BAE Systems. We are using primarily OpenShift, but I'm becoming more interested in sort of the inner workings of Kubernetes in general as we sort of expand our platform offerings for the various projects that we host. So I'm also here from an end user experience. Yep, that's me.
Okay, seems that's everyone who wanted to introduce. Yeah, it's very nice to see. Like we have a lot of different folks from different areas, and basically this working group needs a very big variety of like use cases and like different views on different things from different perspectives, from like the cluster maintenance perspective or from like the application perspective. And yeah, so like as we have seen like in our caps or in this charter, there is a lot of actors that need to be reconciled to get like the desired behaviors. Okay, I will go back to the agenda. So me and Ryan have submitted a proposal for the contributor submitted in Atlanta. And so we hope it comes through, and then we could schedule some meeting there. Yeah, Ryan, do you have something else to add to this?
Not much. I mean, I think I guess I'll just state like the goal. I think this working group is just getting started, and I was hoping we could use if we were able to get a slot at the Maintainer Summit, that we could use the slot in person to talk about. We will do. I mean, we do a little presentation about like what the goals are to the larger community, the larger developer community, and then it could also be a good spot for all of us to get together and meet up and even discuss further things that we're interested in.
Yeah, and I think we hope to move forward a bit with our efforts until the summit comes up. So we will have more things to discuss there. Okay, so like first I have added this topic about the eviction requests. But if or maybe we can conclude the organization a bit more. So like as it is today, like most of the things are complete. So we have a mailing list and a Slack channel, and like the main thing that's missing is a Zoom account and the YouTube account. So we are pursuing that like still, but it takes some time to get that. So we are lucky that we have folks from cloud provider helping us with hosting these meetings. So expect in like the upcoming weeks we will change the Zoom link to update it to the working group Zoom link. But until then, we will use the cloud provider resources. Okay, so unless
Hey, Luke,
someone, Yep.
Maybe just as a resource. I don't know if you have it here, but is there a link to the mailing list? Maybe we can just have it somewhere.
Yeah, I think you can see it from our, like if you do to the, but I can also add it to the document. So we have the link to the mailing list here.
Yeah, that'd be great. Just so people can find it while we're getting started.
Yeah, I guess I can. Okay, I can edit just now. Okay. Okay, so if you join this Google group, you will get automatically subscribed to the mailing list, and you will also get an invite to the calendar and our meetings. Okay, so unless anybody has something to add or like to discuss, I mean, I suppose like the future agenda, we can go ahead with the eviction request.
I have some stuff that I think is tight enough that if you start, like I'll come in.
No, like please go ahead. Like we
No,
can.
honestly, please I think when we don't have I want to make sure everyone's in the same context on what eviction request is first. Like I know me and you like quite deeply know, but like let's get everyone up to speed and then I'll come in.
Okay, cool. Yeah, yeah, Lucy has some follow-ups there, so that's very good to have. And okay, so let's go to the cap. Okay, so here we are. And so I think like the general idea behind the cap is, so we have started with the node maintenance cap first, and uh, since there are like many problems with pod disruption today, like mainly how these pod disruption budgets work and how this is reconciled in the cluster, like for all the actors who are doing the maintenance, if how they use the disruption budgets, or like if they are blocking the eviction requests. So there is a lot of ways how to achieve things, but some of them are like pretty convoluted. And so when we are looking at the non-maintenance cap, we've tried to come up like with a better eviction mechanism. And so this had like some evolution behind that. And basically, first what we tried to do is come up with like some simple conditions on the pod where we could like block eviction or like postpone the eviction until like some condition appears on the pod or annotation. But like since there are a lot of actors, this had like some major drawbacks. And then it flipped to like a bigger API, which has this like purpose built in. So like to first like to maybe to highlight some things from the motivation section. So like as I have said, like there are some problems, but that's pretty generic. So like one of the problems is that it's very hard to run an application which has like a single replica or single pod, and basically keeping its availability through all the like a node lifecycle itself or like any other disruption. So like in general, like in normal case, you would use like a PDB to achieve like availability and achieve it basically like through multiple replicas running and allowing only some of the replicas being down. But this is not possible with a single replica. So you have like two options. You either use a PDB and make it blocking, and in that case, anyone who is doing like a node shutdown or like a cluster upgrade or any other action on the node that wants to basically drain the node and remove all the replicas, they would run into this problem that the PDB would be blocking, and without like a deep knowledge of the application, there is no clear path what to do next. And in a case you do not use a PDB, you basically will be evicted, and you do not have a chance to reconcile. So let's say you do not your application does not require high availability or cannot support it. So for example, if you are running like a single replica database or a virtual machine, you cannot like support HA, and in that case, you would be disrupted. Like this has some solutions, and yeah, like we can see them later, but like that's like I mean, like the main solution is like through validation webhooks. Like that's like a couple of some projects are using. But this has like a very big drawback of like observability. So it's like validation webhooks are not observable, and if something bad happens, basically you can have like the pods not reacting to eviction, and there is no clear path forward as well. And it is also hard to achieve some communication between multiple actors. So basically you can have like one actor implementing the webhook, but sometimes you might need more actors that would like to know about each other, and it's very hard to do. And yeah, and there can be like bugs in this process. So this is what this API is trying to achieve, to basically bring in the observability and bringing some like communication process, or like through the single API to achieve the eviction. And like the other problems are like in a similar vein. So as we saw with the single replica application, you cannot also use like HPA with this. If your HPA downscales to a single, you will run into same problem. And also the PDBs are not dynamic, so you will basically need a controller that will keep up with the scaling and basically tune the PDB over time. So this was also like not designed with I mean the PDB. So the PDB was not designed for like single replica applications or for like some more dynamic environment or some more dynamic processes. So there is like it's like, yeah, it's hard to reconcile basically. And the other points are so basically when you have like any termination mechanism, like in like today, for example, when a replica set is scaling down and wants to remove some pods, or like basically even any other process in the cluster that just uses eviction call, and later I will follow up on also the deletion calls. And in some way, like we would like to have an option to basically intercept all of these evictions or deletions, and like inject like a custom behavior that would happen, like that would help, for example, with scheduling. So a replica set has like these bunch of issues when you are downscaling the replica set. You can disbalance the pods across the nodes and basically like go against the scheduling constraints. And this would help us to basically like inject the scheduling logic into each controller. So we've had like a couple of proposals that try to implement this, like to try to bring in like quite heavy scheduling logic into, for example, replica sets. But this is a major drawback of basically re-implementing the same thing in many controllers, and it's a maintenance burden. So basically, you could implement this in a replica set and have like many toggles, or for the scheduling or the descheduling of the pods. But we would like to outsource this to some other component, and it could be also done with like the eviction request. The other part is the descheduler. like we also like the deschedule project has already implemented like similar behavior to eviction request. We have had discussions in this CAP, and so basically we have tried to come up with like intermediate solution for them. And so basically they are using annotations for now, but like in alpha, but in the beta of the feature, they would prefer to use like a more defined API, which would be the eviction request. And this is for like achieving, for example, for the descheduler, like to allow applications to achieve some migration capabilities before they are evicted or deleted from the node. And basically this descheduler adds special annotations that allow like postponing the eviction until the application has migrated or has done like sufficient cleanup until it can. Okay, some other request we've had was like regarding the resource reservation. So this is basically task of making sure that we have enough resources in some other like suitable node before we can delete a pod. And so basically, again, you need a signal to first let the user or the application know, like we try to delete this pod. Like there should be some like better like termination or graceful termination mechanism behind that. And if you can assure first that we have enough resources before we can migrate. The other part was also graceful deletion of pods, like that we have daemon set pods, but it's pods in general, like in the graceful node shutdown feature, which is already like beta for some time. And this feature has like some issues regarding the communication and the gracefulness of the node shutdown. So again, there is like some considerations. Some nodes we would like to have like a faster shutdown, and some slower. And in the slower case, we would like to allow the applications to basically migrate or clean up before they are fully terminated. Okay, I will get to this last point later, but okay, let's first take a look at the API. That might be more interesting. Okay, so first let's start with this. So we are still we are still using some annotations here, even in this case. So the first part is that if we have a pod that is controlled by a controller, and the controller has some migration capabilities, they should first advertise these capabilities. And it's done by setting an annotation. And basically there is like interceptor class, which is, for example, this field. So it could be, for example, like a replica set could be also an interceptor, or the deployment could also offer some migration capabilities. So the deployment controller, for example, in this case, would set this annotation on pods that it knows it can support like a better, like a graceful like termination or migration behavior. And then we have a priority and some like metadata, or some like we call it a role, but this is not defined. So like any controller can write anything here. And like the advantage of this is that multiple interceptors can actually communicate through the pod their preference of like the priority. So some controller knows, for example, about, or some interceptor knows about some other interceptor, and it knows it would like to run it like before that interceptor. So it can actually go through the annotations, find the interceptor, and then write one higher priority than the controller before, or for example, the last interceptor that will probably delete the pod, and you want to do something more clever before the pod is deleted. So you would set higher priority. So in one like iteration of this eviction request proposal, we did not have these annotations, and we basically first created the eviction request and then let the interceptors or fight for the control. And it's much more complicated and also resource intensive, so it's much better to basically advertise this before, so the controller or the interceptor knows that it should reconcile this annotation, so it is always on the pod, and it knows it will be called after if when the termination is or the eviction of the pod is occurring. And so, okay, let's go to the API. So the main part is obviously the pod reference, like which pod we want to evict. And this should be like the main required field. So just similar to the eviction API, which today we have, which is imperative. But it is lacking features. But this is like a declarative version of the eviction API we have today. And this field, interceptors, would be actually filled or looked up from the pod. So we expect each pod, as we see before, to have these annotations, and if it has them, we will, on admission, we will fill in the interceptors field. Like you can add some extra ones, but like the API should be simple from the user perspective. Just like have the pod name and run the command, or like for the controller to run the command. And this is important part, the progress deadline seconds. So yeah, I have not mentioned the main actors, so let's go through these before I mention that. So first, okay, not here. Yeah, so first we have the eviction requester, which usually is for example today is like a kubectl drain, or like a cluster autoscaler, or for example, as we saw, the descheduler. So usually like users do not use the eviction API directly. Like today, there is no support in kubectl to even like run the eviction request. I mean, like you can run it through the kubectl, but it's not easy to do. There is no like a command for that. So like normal users, so we do not expect there to be like a big set of eviction requesters, but I mean mainly the components who are interested in triggering the node maintenance, or interested in the node lifecycle. Okay, and then we have the interceptor. We've discussed this before, which intercepts these eviction requests. Okay, and then we have the eviction request controller, which basically handles this whole API, how it behaves, and what are like the constraints of the whole process. So like the problem we have today with PDBs and eviction is we are lacking an intent of the eviction, so the eviction happens straight away. And we are also lacking communication between all the actors. And if somebody does that, it's basically overriding the other. So when you create, for example, the validation webhook, if the validation webhook does not work correctly, you are blocking the node drain. And for example, it depends also how you set up the node drain. For example, if you have the node autoscaler, or even when you, for example, if the kubectl drain, you can override it by just deleting the pod. So like you never know like which cluster is set up in what way, like what behavior is safe and what is not. So like we try to implement this behavior, but we need to have also some like hard maintenance to basically achieve cooperation. And one of these like ways how to achieve that is the progress deadline seconds. So to make sure that, for example, the node maintenance, or I mean the node drain, doesn't like stall or is not blocked like infinitely, we basically allow or expect each interceptor to basically call back and give us progress on the eviction process. And if we do not receive like this progress in this time, we will like switch to the next interceptor, to the next priority. And so we always are sure that in a reasonable time we know the pod like will leave the node. But if the like interceptor is responsive, it can take a long time, but we are know it's working, that the pod like graceful termination is working. And like one of the last interceptors, like it's not like in the interceptors field, but is this eviction request controller. This controller guides the whole process. And when we get to the last interceptor, or if there are no interceptors, we will basically call the eviction API, the imperative one. And we will try also to like substitute or replace like today's controllers who are calling the eviction API, for example, with some delay. If the eviction request does not pass through, then you need some delay and try to call the eviction again, until it succeeds. So this eviction request controller will do that. And so basically you as a user, your only worry is creating the eviction request, and then you know the pod will be gone. You don't know when and how, but it will be gone. Okay, and then the next part is the status of the eviction request. And here we have basically the fields for the communication. So the eviction request controller will choose the interceptor and write the interceptor class to the status. And the interceptors will observe this status, and when they see their own class, they will start like their process for the graceful termination. It doesn't have to be termination. It can be, for example, even some logging, or like calling some component. Like it can be anything. But it's expected that one of the last interceptors will call will implement the termination of the pod. And then once the intercept, or in the meanwhile the interceptor is working, it should update this progress timestamp, which is which is then counted against the deadline. So, for example, each 10 minutes or 15 minutes, it should increment the timestamp. So we know that the interceptor is working on the termination. And it can also give us a finish time. And once it completes, it gives us completed. And this is also the then signal for the eviction request, or the eviction controller, to bump it to the next interceptor. Then we have like some other fields which are not that important. One is, or it can be, but these are the main ones to make it working. And then we also have the field for the cancellation policy, if we can cancel the eviction request or not. So in some cases it might be desirable to cancel it. So for example, if we have a change. For example, if the node in the node scaling, we see that the node should be drained, but in some time we see it's not needed anymore. We can cancel the eviction request, and the controllers who have not picked up the eviction can keep the pods running, or they can like have a behavior to revert the eviction. But some of the processes, for example, that are doing like heavy migration or have already started to shut down some processes, might advertise through this field that it's not possible to cancel this eviction request. Okay, and these fields are not that important for now. Yeah, sorry about the noise. Yeah, I can guess I can go quickly to the eviction request process and show you in the diagram how it looks like, and then we can discuss a bit more after that. So here you see all the actors we talked about. So for example, first I would like to say how it connects to the non-maintenance cap. So when we will introduce the non-maintenance API, we would like it to not just be API for like tagging nodes, like which are good for maintenance or not. We would like to have like a more better behavior to basically achieve to basically have the same thing for what we have for the eviction. So when you just create a pod or the eviction request for the pod, you know the pod will be removed. Even the same for the node. You just create node maintenance for a node, and you want all the pods to be gone from the node. So basically, we are trying to also make the kubectl drain command to make it declarative. So for example, we would use the eviction request from the node maintenance, and then we would go over all of the pods on the node. We would create the eviction request. And as we see, we have the interceptor, which set the annotation of the interceptor class on the pod. Then the eviction request controller will see the eviction request, will select the interceptor, and it has to also reset the status of the eviction request. So the next interceptor has like a good starting base, and then the interceptor will do the magic. So in case in the deployment controller, we know that we have some deployments that could have like a better behaviors, for example, using max search. And in this scenario, we would like to first search the deployment, for example, 1, 2 replicas above. And once the new replicas come up, we would basically search down again. So like if deployment controller implements this behavior, we could have like a smarter way of dealing with disruption, like across a set of applications which are already existing. And so this is an advantage of this like approach, that it's like plugin. So like in the baseline, the behavior will be the same as before. So if you do not implement the interceptor, if you do not implement a special controller, you just create eviction request and it will pass through like the imperative eviction. But you have a way of saying, I want something more. And we can also implement this behavior already in the upstream controllers, in Kubernetes controllers, like the deployment. And we can also experiment with some other options in other controllers. And as we saw before, you can even, if the deployment control implements the interception, you can have like a more specialized controller that your organization could implement, and it would have higher priority than the deployment controller, and it could basically even prepare your application for the termination, or have like a different way of terminating the application altogether. So we start the eviction process, and then the important part is we should update the progress. So like, yeah, I understand like this is like difficult to implement. It's like for the person who is interested in just the graceful termination, it's a hurdle. You basically need to call an API in in periodic time. But it's necessary to actually like achieve like good behavior across all the components. And if we see that some pods are blocking the node drain, we can then easily list all the eviction requests and see who is blocking what, and we can debug further. It should be easy to debug. Even the deployment controller or other controller can like send our messages or conditions through the API. And yeah, so basically we would have like an easier time to get unstuck from the node drain. Okay, and once, for example, the max search is complete, we can terminate the original pod, and this would be over, the pod would be gone, and then we can garbage collect the eviction request object. Or you can even pass through to the original eviction. So as you can see, there is like multiple paths you can take to undergo the eviction or graceful termination. Okay, I've talked for a long time. Okay, does anybody have thoughts on this or questions?
Why don't I? Actually, does anyone else want to go before I go? I will take silence as consent. Okay, so one of the things that you mentioned just there at the end, actually, which I think is quite interesting, is you mentioned, okay, we have conditions. So if the interceptors can indicate information about the status of their progress on what they need to do for the eviction, and can indicate blockage and things like that, right? What about the people actually causing the eviction request to be created, the evictors themselves? Should they also use conditions to communicate? For example, as an interceptor, how can I tell the context in which a pod is being removed, or in which an eviction request is being created? How can I tell whether it's taint manager or whether it's something a user space person is doing for reason A, B, C, X, Y, Z? How can I tell if I wanted to pick between two pods that had eviction requests? Where do I get the context to make a prioritization decision? Is it through conditions again, and you expect that the evictor makes those conditions on the eviction request? Or is it something else?
Okay, so I don't know if I have fully comprehended your question. So you are asking about the eviction requester, like if you have like...
Yeah, earlier you said interceptors can create conditions to indicate, hey, I'm doing this, or hey, I'm blocked by this, right?
Mm-hmm.
Okay, and my follow-on question was, how do evictors indicate why they want something evicted? How do I indicate, hey, I'm evicting this because it's the node is tainted in a way it can't tolerate. Hey, I'm evicting this just because I found a better place to schedule it instead. You know, high priority, low priority, anything in the middle. Conditions? You're muted.
Yeah, sorry. Okay. So first, let's go back to the API.
Yeah.
Okay, so I mean, I have described in the CAP how the process should look like, and we've tried to make the API as simple as possible for the evictors, because we know there can be multiple of them.
Yes.
And so basically that's why we want the interceptors to be by like defaulted. We would like this also to be like set on the default. So if you have like multiple evictors, each one could set like a different value. And so we have like like this interval between 10 minutes and 6 hours. But we hope that we will not have to use it. So if we have multiple evictors, we would like them to stick to the default, and so we don't have to deal with like with the communication about about this value.
Okay.
Yeah, let me continue. So yeah, I'm just and so basically now the communication is only through the eviction request object and about the cancellation policy. So if you have like multiple evictors and you see the eviction request that somebody else has done, then okay. So I think
I don't think we like. I'm sure we can say like we use conditions, but I don't think in any way we set any opinions. And I know that we want minimum viable products. The only reason I think this has to come up is because, for example, you said earlier, like tape manager should eventually create eviction requests, right? Well, if it's going to do that, it needs to include context as to why it's doing that, aka non-tolerated tape. So there has to be some schema at some point. And if we don't set anything, then people like me and also other people in different companies are just going to run off and make their own standard. And then the reconversions is not going to be fun.
Yeah. Okay. So one of the things I'm outlining in this gap is that we have some information. So when we have the eviction request, we would like each evictor to set a finalizer who is doing the eviction. So we know at least about the set of actors that are interested in evicting of this pod.
Yeah, but that's like we know who's interested, and that doesn't mean we know why.
Yeah, the why is not covered yet.
I think we do need to make sure there's somewhere for it, even if it's conditions.
Yeah, so for now, like we expect like that you could, for example, have the known maintenance and understand that it's because of the known maintenance. And yeah, I know it's a simple API first, but like one of the things is like the interruption or the cancellation of the eviction request. So if you have like two actors or two evictors, for example, the known maintenance and the descheduler interested in removal of one pod, they can set the finalizer, and one of them then cancels the request. Then it can just remove its finalizer, and the eviction request still lives on. So we have like a cooperation on this level, on the finalizer level. And when there is no other finalizer, then we can delete the eviction request if it is possible, because interceptor can also, yeah.
That's fair, but that's I think that in general, I expect interceptors to treat the finalizers as more of opaque things of you can know who is asking about eviction, but I still don't think even with messing with the finalizer, you can truly set a good standard for understanding why. Yeah, I think I just think that, and to be clear, I know the more stuff we add, the more annoying it is. But yeah, exactly, JP, you've got it nail on the head there. But I know the axis of why is hard to completely agree on. I just want a way to express it. Even if for now, and I have no issue with this, even if for now, we're not talking, actually, why do I say for now? Even if we're not talking about prioritization, it would be nice to at least have enough information that if I am writing an interceptor and I'm like writing it, okay, if I'm writing an interceptor, I want to be able to say, hey, look, this pod here wants to go away because of this reason, but which I've gained from the eviction request. This pod here wants to go away from this reason. I'm going to treat them differently because of these whys. For example, if I'm draining a database from one node to another, I might use some of the bandwidth, not much. If it's like, oh, it's just moving it around optimization. I might use a lot more if it's like this machine is not very good. Anyway, go ahead, Philip.
Okay, so do you want to? Yeah, I got lost a bit. I will let Jonathan talk, but do you want to solve the interceptor communication or the evictor communication between the evictors, or interceptors between evictors, or
I just want to solve that, and it doesn't even have to be something that is standardized in a prioritization way. I just want to solve in an opaque way that an evictor can pass a context. Okay, so an evictor can tell an interceptor why they're doing this. It's up to you to understand that why. Fine, not a problem. You know, you can just do it through conditions. But I would at least like us to say this is where that communication channel is. Jonathan, you've got your hand up. I've been talking a lot. Say something.
No, I think it's a good point. I completely agree. Intent matters. I think I'm kind of curious. I haven't been around this API or this kind of proposal for too long. I think I read it for the first time last week. I was trying to understand like what the reason was that we felt, and maybe it's like an organizational / like stability question, but like what the reason is that we felt that we needed a separate API for this entirely. Like why could we not just extend the existing like eviction sub resource to, you know, be more expressive and have details in the pod that basically gives us more information around intent. Maybe have something like eviction finalizers or something like that. That then, I mean, you have to communicate priority through eviction finalizers or something like that. But I'm just curious, like, why we need both APIs in place.
I think when I think about this from an Arch side, I think that back compat wise, I would say that it is conformance based that eviction objects either get created and blow up the pod, or they get 49'd, right? I also which is special and is something that back compat wise we kind of have to keep. It's quite hard to mangle this with that, especially because nowadays in the current system, eviction objects, right, are one shot binary yes no. It either gets created and then you assume it worked, it's gone, or it doesn't get created and you assume you can't do that right now. If you were to try and mangle these two things together, you would have to get it created, but it's not actually blown up the pod yet. That to me is back compat problematic. Like if you've written code for like current K8s, I could easily see a code path that goes, create eviction object. If no error, then pod is gone, do code. That code will break.
Yeah. I mean, I totally appreciate the fact that you maybe can't use the existing eviction sub resource. I'm just trying to understand. So like ignore like reusing the existing eviction sub resource. Imagine you create eviction sub resource v2. Like what is the like what's the need for having both these APIs in place? Because it feels like we're trying to coordinate between like the pod API and this eviction request API, just so we have this like dual communication and things can like understand what's going on. But like why have that in the first place? Like what's the need?
I mean, I think it's not that big a deal whether it's a V2 eviction or eviction request. What I would say is, at least to me, when I think about it, and please people just jump in and just shout over me if you need to. I work at a company where a lot of people talk a lot, so I have to just keep talking. I think that eviction v2, eviction request, sure, they exist separate API types. I do think that it would be kind of confusing to users if suddenly the eviction v1 object and the eviction v2 object behave very, very differently. I do get that like new API type, people have to learn. I think that one of the things that I always think when we make changes like this is complexity wise, is this okay? Are we introducing too much complexity? But I don't think that changes depending on what form in the API group it takes. It's more about the content and its behavior that matters to me there. So yeah, that's at least my opinion, but please other people talk.
Yeah,
Lucy,
yeah, go ahead, sorry.
I just want a clarifying question. Lucy, would you say, because you said 429s on the eviction API, so like meaning we you did an eviction and the pod disruption pod disruption budget blocked your eviction, right? So
Yeah.
so the change in behavior would be right that now we're saying that we're doing some sort of coordination so that you would not run into this, right? You wouldn't run into some sort of pod disruption budget blocking it, and that would be the behavioral change.
Well,
right?
if we mangled eviction request and eviction into one object, then the behavior changes. Eviction request gets created and then does its thing, right? Eviction tries to do its thing and then gets created and blows itself up. And I definitely think there are a lot of code paths out there that people have written of try to create eviction object. If there's no error, then the pod is deleted. We can do our thing. That expectation would break, but I don't think we're going to mangle these two things together for that reason and everything else.
That's what I wanted to clarify for Jonathan. Yeah, because I think that's the point. I think maybe that's the sticking point is like for this is that the pod disruption budget with the current eviction API, if we were to if you changing that behavior, it sounds like would cause something to be, breaking. And so that's like the major change, right? Is that we're sort of treating the PDBs a little bit differently. And I think that's the suggestion why it needs to be something else, something different.
Yeah, and just for the context of people who may be new to K8's contributions and everything, in general, we do everything we can to avoid backwards incompatible changes. We try and back compat all the way back. So this is why this discussion is happening.
Yeah. I'm not, so maybe that's the bit I missed. I'm not yet I wasn't yet convinced that this was backward incompatible. So we're talking about completely changing the way that we're using PDBs entirely. Like the way that I read this was that it's like a pre-step before we actually consider PDBs. Is that not?
I would say that. I think it is a pre-step, but Philip, you look like you've wanted to talk for a while, so I'm gonna.
Yeah, you have basically summarized it well. So the declarative, or sorry, the backwards compatibility is very important, and as you said, we cannot change it, and you can enhance it. So we have looked at how we could enhance the eviction, like the imperative eviction, and as Lucy said, like the problem is with the model. So you have the expectations that like the eviction will go through and the pod is deleted, so you do not have like any like window to react. And we have even talked to SIG-Arch what would happen if we, for example, when you call an eviction and in the meanwhile the eviction process is running in the API server, you call other endpoints, for example, that would tell you information what you should do next. But this is like very difficult from the performance and security perspective. So you cannot just call from one endpoint set of like bunch of other endpoints. It's like very hard to do, and people like Arch folks are against that. So that's a no-go. And also enhancing the PDB itself is not so straightforward or easy to do. So that's why we came up with this API. So basically, we acknowledge the old APIs, for example, the eviction and the PDBs. So we cannot remove them. We have to acknowledge their behavior. So we try to build up on top of them. So we can keep the compatibility, but expect the people who would like to use these nicer behaviors to basically opt in. And the other folks who have not started using these APIs, they can still use the old ways.
Yeah, it makes sense. I mean, I think whenever I typically attack these designs, I totally appreciate that. Like, I am way behind where y'all are, and y'all put a ton of work into this. So like, I will catch up, I'm sure.
I wrote none of it. I just read it like 5 times.
Yeah. Yeah, it's like I think whenever I'm thinking about these design questions, it's always like the constraint of backwards compatibility kind of comes as the last thing, right? You think about like how do I build this thing? How would I ideally build this thing? And I'm curious if we didn't have the backwards incompatibility constraint, and I get that's there, but if we didn't have the backwards incompatibility constraint, how would we build this? Because necessarily like introducing another API does introduce complexity, and it's like we do have that. And I find that like just my initial read of the KEP is like I found it's a bit awkward, like the communication between the pod and the eviction request and how that's coordinated. And we have a lot of like naming standards in there which are kind of awkward, and I kind of question like whether the API should be more like strongly typed. I think there's some comments in the KEP about that.
I mean,
yeah,
that is fair. Like if we could go back in a time machine and fix all of the API mistakes we've made in K8 over the years, I'm sure we would. But to me, I think as Philip said, like as a Kubernetes user, if we express it in the way that we have in this KEP, you have the option, but not the obligation to learn this system, to use it. If you're a power user and you need this, it's here. If you're a hobbyist on like a home lab, you don't need it, and that's fine. Or if you're a small business, it's fine. It's you don't have to relearn this. I think that's good. I think increasingly as Kubernetes has evolved, we have to be careful about not overloading users with new things, and complementary helps that. But also in making sure people use Kubernetes in ways that we would never guess. And we have to make sure that the APIs are expressive enough, not to the point of ridiculousness, opaqueness, but expressive enough that not 100% of use cases work, but 90% of use cases should have a great experience on this. I know it's a balancing act. When I think of this I think it's at an architecture level, I think it is solving the right problem in generally the right way. I have comments and questions and concerns about some sections and details. I've only talked about one so far, but at the overall arch level, I do think that this is probably the right way, and it's probably the right problem right now. But that's just me.
Just want to add one thing to that. Oh yeah, we have to close this meeting soon. We are a bit over time, so sorry everyone. Yeah, regarding the complexity of the API, yeah, I am like open to like any suggestions to the CAP how to improve it. Like that's for sure. But we would like this feature set to be there at least. And I think like the main selling point is, as also Lucy said, this is not like the user-oriented API. This is more like the machinery running in the back, like in the behind. So, for example, we have looked at the evictors. Like there is not like that many components who are running the eviction. So, like users just expect like the things to work. So when they run like node auto scaling or something, they expect it to work, and unless they have to then configure it. But that's the other like story that we don't have time for. So yeah, like any last comments before we can close this? I think we can follow up later, like what Lucy said, for example, about the eviction interceptor communication, and yeah, we can follow up on this CAP. So please, last comment.
Just before we close, does anyone who's not spoken yet have any comment or have any question? It doesn't matter how silly it is. We've all been there, and that, from what I see on my screen, that's I'm sorry, I've forgotten your name. It's been an hour, but Seaborn, Daniel, Caitlin. If there's anything you want to say, like it doesn't matter how basic it is, like that's fine. Completely up to you. If you don't want to say anything, that's also completely fine.
Yeah, I mean, I think that most of this is over my head since I'm just getting into sort of the back end of how Kubernetes works and how it's enhanced. So I've learned a lot just by listening, but I'll probably be quiet during most of these meetings. But I appreciate it. Thanks, everybody.
Absolutely. If you have any questions for any of us, you can just DM us on the Slack. Daniel, I saw you unmuted. That means good things, right?
You're good at spotting this. So I totally agree with you, Lucy. I can definitely see the problems, and I am reading through the CAP, at least through the beginning of the CAP. It feels like it's solving a lot of problems we have solved in very weird ways internally. So it could help us deprecate some of the things we are doing. And yeah, as you also said, I have a couple of questions that are going into more specifics, but overall it looks pretty good already.
Nice. Building the right thing's always very important. Jonathan's put a question in. I can't read it because it's on a big TV in the chat.
It says, one other question that I had, what's the interaction between problems that are solved with termination grace period and the ones that we want to solve with eviction request?
Good question.
Yeah, I think like we will have to follow up on that in the next meetings. We are a bit over time. I'm sorry, like we don't have more time, but we would like to respect like each other's time. And yeah, we can like you can also like write the follow-up questions into our agenda doc. Like we can go over these questions, for example, in the next meeting. And even if you do not have like much experience with the Kubernetes like contributions or with these caps, like any feedback is welcomed. And even like we are like with this working group before, we are looking for the use cases, so we know we are actually solving the right problems in the right way.
We all started somewhere. Besides, I'm a lead on this working group, and I crashed my home lab Kubernetes cluster just last week. So.
Okay, cool. Thanks everyone, and see you next week.
Thanks, everybody.
Thanks.
Oh.